7.3, the last homework assignment of this class. It's a pretty short one, not a whole lot to do. This is where we did diagnostics on the LSR line. So we already know how to make our LSR lines, but what do they tell us? What do we got to be careful of? Okay, so for this first one, what you have are all these observations here, and then the one up here. This observation has an X value significantly different than the rest of your X values. Think about what that tells you. Identify the outlier, and determine what type of outliers they are. Okay, this outlier, this is the outlier out here, right? It's the one up in the top left. And the question is it influential or not? Well, the definition this uses for influential is, without it, would you have a significantly different LSR line? Yeah, of course you would. If this wasn't here right here and you tried to draw the LSR line, it would look like this, right? It wouldn't look anything like this. So the outlier's in the top left, and yes, an influential point. Same idea down here. The outlier down here significantly, and that's a bit subjective, influences your LSR line, because without this, the line would look more like this. All right, so I guess not quite as much as it did in this one, but it's still changing it in a visible amount, significantly as your book calls it. So it's influential as well. Whereas down here, the outlier is way up here, but note that its X value is not significantly different from the rest, and that's causing it to not be an influential point. I guess I just told you the answer for all three of these. I don't know. This isn't the greatest homework assignment. If you get anything out of it, great. Question 2, they give you actual observations here, X's and Y's, and you're supposed to make a scatter plot. And you're like, why am I making a scatter plot? That's what I did in 7.1. Well, one of these observations is an outlier. And you might be able to tell which one's an outlier just by looking at them, but you'll definitely be able to tell which one's an outlier if you make a scatter plot. So the logic is make a scatter plot and then determine which point is an outlier. And note you want to enter it as an ordered pair. So like this, right, with parentheses and a comma in between. Figure out which one your outlier is. And then figure out your LSR line without the outlier and figure out the LSR line with the outlier. And what you're supposed to do is enter an equation in slope-intercept form with parameters rounded to 3 decimal places. So what they mean is y equals 1.234 x plus, I don't know, 456.789. Sure. It's written as an equation. So y equals, I think there was one in a previous assignment where you didn't put in the y equals part. And then something, x plus something. Use a lowercase x, lowercase y, and the equal sign. This is your LSR line without the outlier. You'll do something down here for the LSR line with the outlier. My advice, you're typing in all these observations to make your scatter plot, right? So you have these all in L1 and L2. Figure out your LSR line and answer this third question, and then go back to your data and delete that outlier and then answer your second question, right? If you do them in that order, you won't have to insert new observations or do anything weird. At any rate, you're going to have these two different LSR lines, and I think what you'll find is they're probably going to be significantly different. So yeah, the outlier is an influential point. Sort of the idea. Question 3, let's see, we've talked a lot about influential observations, but we haven't talked about extrapolation. Here's an example where they talk about parents. I think I gave this exact example in the homework, whatever. Recording a kid's height until he's 66 months old. And then they're going to make an LSR line of his height. All right, so picture age down here and his height up here. And then they're going to use that LSR line to predict his height when he's 252 months old. That doesn't make any sense. I'm only using observations up to 66 months old, and you want me to predict 252? I can't predict values of X that are significantly different than the values of X that I used to create the LSR line in the first place. Because if I do, that's an example of something that we learned about in our class that could be misleading. I don't know. I guess I'm telling you the answer for this one too. It's the last homework assignment. What are you going to do? The whole idea here is they're supposed to give you an example of extrapolation, and you're supposed to recognize it. So that's a 7.3 homework assignment.